Okay, 4-3 number theory for fractions. This section, you're not going to love it because a little bit of it is stuff that's a little bit abstract, trying to prepare you for the future, and factoring and distributive property and things like that. So this part says factor the sum of terms as a product of the GCF and a sum. This is a good application of GCF. So here's a sample question, okay? Here's example 1. My numbers were 12 and 16. So it says to factor the sum of terms as a product of the GCF. So the first thing I need to figure out is the GCF for these two numbers. So I can do trees. Okay, this would be 4 times 3 and this would be 4 times 4. They both have a 4. 3 is prime, so it doesn't matter that I can factor that more. My GCF is definitely 4. So you put 4 outside of the parentheses, and you're going to show the product by using parentheses. And then you say 4 times what is 12? 4 times 3 is 12. And 4 times what is 16? 4 times 4 is 16. So this is the answer of factoring this sum of terms of the product of a GCF and a sum. By the way, if you couldn't do what I did with 4 times what is 12 and 4 times what is 16, you could divide it. 12 divided by 4, 16 divided by 4. 12 divided by 4 is 3, 16 divided by 4 is 4. Also point out that 12 plus 16 is 28, and 7 times 4 is 28. So I would do this because these are equivalent expressions. Okay, they both mean the same thing. Let's try again. Let's say I have 18 and 30. Okay, so let's factor out 18. Let's factor out 30. 18 is 6 times 3. 30 is 5 times 6. They both have a 6. These are both prime numbers, so I don't need to, my GCF is 6. So I factor out the 6 and either do what I said about the division. 18 divided by 6 is 3. 30 divided by 6 is 5. Or say 6 times what is 18? 6 times 3. 6 times what is 30? 6 times 5. This would be 48. This is 8 times 6, which is 48. Here's my answer. Okay? Now, they can throw a letter in here. Let's say I have 24x and 48. Okay? Now, make sure I have, so if I do 24 and 48, I need a GCF. So this is 6 times 4, and this is 6 times 8. Okay, so they both have a 6. But watch, 8 is 4 times 2. So the factorization of both of these also have a 4. So my GCF is 24. All right, factored out to 24. Now 24 times what is 24x? Well, the good news is 24 times x is 24x. Or if you wrote it like this, 24 over 24 is 1, so I have 1x. If it makes you feel better, you could write it like that. And then I'm dividing 48 by 24, so that's plus 2. Okay? Second part of this page says to write 4 equivalent expressions for each given expression. Okay? Let's say I had 40 minus 12. Okay? 12 minus 10. So there would be, and it said 4 different ways to write this. So, and it says an expression, not a solution. So the trickiest thing is you want to say 30. The answer is 30. How about 10 times 4 minus 1? That's the same thing as 40 minus 10. What if I wrote it as 5 times 8 minus 2? That's an equivalent expression. What else could I do? What other choices do I have? I could factor out other things. I could factor out a 2. If I only factored out a 2, that would be 20 minus 5. Okay. And how about a bigger one? What if I did like 400 minus 100 divided by 10? That would be 40 minus 10. So there's a whole bunch of ways you could show this.
Please pardon the interruption. Many parents are calling in that they are going to be late. If your mom or dad is not here on time, please go to homework club. Thank you.
Okay, here's another question in here. Now this time they both had n's and they both have a 5 in them. So I'm going to factor out 5n because there's a 5n in here and a 5n in here, and I'm going to do my parentheses, and 5n times 1 is 5n, and 5n times 3 is 15n. Okay? I know you're going to struggle a little bit with this, but we'll talk about it more tomorrow, and good luck.